Hello, students. In this video, I'm going to show you how to do homework 5. All right. Okay. Now let me share my screen with you. Okay. Now let's look at the requirements of homework 5. Here it is the instruction of homework 5. Okay. Yeah, this homework is intended to practice how to evaluate a portfolio with the measures that we learned in class. Yeah, we estimate these measures with historic data and use the results of the estimation as references for investment decision. Okay. Now, yeah, we have this portfolio. Okay, yeah, in this portfolio, we have 4 assets, HYGV, VGT, FTIHX, and BRIFX. Okay, and in this portfolio, the weight of HYGV is 20%. Next one, VGT is 35%. And the third one, FTIHX, accounts for 25%. And the last one, BRIFX, accounts for 20%. Okay, so yeah, we have this portfolio. And now we're going to evaluate this portfolio, or we're going to evaluate the performance of this portfolio. Uh, First of all, download the monthly return data from Bloomberg. The sample period begins with March 2021 and ends with February 2026, so that the sample has 60 month observations. Then from the Farmer French data library, download the Farmer French 3 factors data. This data set consists of 2 parts, yeah, monthly FF, yeah, Farmer French 3 factor data, and yearly Farmer French 3 factory data. We're going to use the monthly data, right? Yeah, in the class. Yeah, actually, yeah, we have downloaded the data from the Farmer French data library. Okay, and we're going to match the monthly data of the corresponding periods with the Bloomberg data. Okay. I think yeah, you can read this one. Please pay attention to the unit of this data, and both data use the percent. Okay, Bloomberg return data and Farmer French 3 factor data. All of them use the unit percent. Estimate expected return variance, standard deviation, and the beta of assets in the portfolio. Yeah, when you estimate the beta, use the data of the Farmer French market portfolio. Okay, so here, yeah, we're going to use Farmer French market portfolio as to proxy for the market portfolio. Okay, because Farmer French market portfolio is the most comprehensive market proxy. That means it includes as many risky assets as possible. Okay. And then following the definition, estimate the Sharpe ratio, Treynor ratio, and Jason's alpha of assets in the portfolio. Now, the fourth one, regressing Farmer French 1-factor model and Farmer French 3-factor model, estimate Jason's alpha, and then indicate their significance. Okay. From step 1, okay, I think here there is a typo. There should be 1, 2, 3. This one should be 3, right? This one should be 3. Okay, and this one is 4. And then this one is 5. Yeah, 5, 6, 7. Okay, 7. Oh, come on. Now this is 8. Okay. So last one is 9. So in total, we have 9 tasks. Okay. So from number 1 to number 4. Okay. I think it is a repeat of homework 4, right? Do you remember your homework 4? Do you remember? Okay. Now let's go to the homework 4 demonstration. Okay, yeah, because actually, yeah, this homework 5 is a continued work. Yeah, homework 5 is a continued work of homework 4. Okay, so now, yeah, let's go to the homework 4 demonstration. I think, yeah, you should remember this homework 4 demo, right? In this sheet, yeah, I downloaded the data. Yeah, I downloaded the monthly data in the past 60 months of 5 assets. IWV is the Russell 3000 index, right? And in homework 4, I use IWV to proxy for the market. And then HYGV, VGT, FTIHX, BRIFX, that these 4 assets are the same, right? Are the same. So what does this mean? That means you don't have to download the data again, right? The data, the sample is the same. Okay, so you can use the data that you have downloaded from the Bloomberg in the homework 5. Okay, so here it is the data. Now, yeah, because this data is connected to the Bloomberg. If there is no connection, we would lose this data. Okay, so now I'm going to copy and paste this data to the other sheet. Okay, to the other sheet. Now in this sheet, yeah, I copy paste this data. Okay, so that I will keep this data. I will not lose this data. Because now, yeah, this is the demonstration for homework 5. So I'm going to save this file. Okay, I'm going to save this file with another name. Okay, I save a copy to my OneDrive. Okay, now I'm going to do the demonstration of homework 5. Okay. Okay. Now we have downloaded. Yeah. No, okay. Until now, I think, yeah, you should know how to download the data, right? We have downloaded the 60-month monthly return data of 4 assets in our portfolio. Okay. In the homework 5 is a little bit different from the homework 4. In homework 4, we use IWV, Russell 3000 index, to proxy for the market, right? However, in homework 5, I require that you use the market portfolio from former French data library. Okay, yeah, I want you to use that market portfolio. Okay, so now, yeah, we're going to download the former French data. Okay, so go to former French library. Okay, actually not former French, actually, yeah, French. Okay, French data library. And now, yeah, we are going to use formal fringe 3-factor data, right? Later on, we're going to use the weekly data. Yeah. So now I'm going to download this data. Yeah. Okay, here we go. Now I open this file. Yeah, this is an Excel file. Okay, here it is the data, right? And in the class, yeah, I have told you, okay, yeah, in this data set, we have monthly 3-factor data, and also we have yearly 3-factor data. Yeah, if you scroll down to the end, then you can find the annual factor data, right? But of course, yeah, we're going to use monthly 3-factor data. Okay, so here it is the 3-factor data. Okay. Now, yeah, we're going to, okay, to be safe, yeah, I'm going to copy this data and paste it on my Excel. Okay, I'm going to copy this. I'm going to copy this and save it in my Excel. Here, okay, I'm going to have one more sheet. Okay, and save. Okay, so now I name this sheet as FF 3-factor. 3 factors. Okay. And now, right now, yeah, I'm going to merge the data. Okay. Our sample period is from March 21 to February 26. Okay, go back to former fringe data. Okay, first of all, I'm going to copy the title of the columns. I'm going to copy the title of the columns. Okay, and now I put it here. Okay, actually here it is a month, right? It is a month. It's the month identifier in French data. Okay, so that is a month. Now go back to former French data. Go back to, yeah, I want my data sample period is from March 2021 to February 2026, right? So yeah, I'm going to search. March 2000, this one, right? Okay, I'm going to highlight this column. Okay, from March 2021 to February 2026. Okay, I'm going to copy paste. All right, copy and paste. Paste in this area. All right. Okay. Now we can see, right? On March 2021, yeah, market risk premium is 3.16%, right? The return on SMB, small minus big portfolio, yeah, in the class, yeah, I have explained what the SMB is. SMB represents a portfolio, right? A portfolio. In this portfolio, we have long positions and short positions. Short position, long position is a small size portfolio, and large position, short position is a large size portfolio. Okay, and then then we can have this long position and short position portfolio. Then we can measure, we can observe the return on this portfolio, right? Okay, so this is SMB, this is HML, high minus low, right? High minus low. That means high book to market ratio portfolio minus low book to market ratio portfolio, right? And this one is a risk-free rate. Okay. Now, we want to have the return on the market portfolio. So what is the return on the market portfolio? Of course, return on the market portfolio should be market risk premium plus risk-free rate, right? Plus. So I'm going to calculate market return on market portfolio here. That is return on market portfolio. So that should be this one, this one plus a risk-free rate, this one, right? Okay, so that is the return on market portfolio. Okay, be careful. Okay, so this column is the market risk premium, and now we calculate the return on market portfolio. Okay, and now I'm going to move my cursor to the right bottom corner and then double click this cross. Okay, then we did all of them, right? We did all of them. I will get this. Of course, after we merge the data, this column is redundant. Right? This column, because this column is the month identifier, right? Maybe I can keep that. It doesn't matter. It doesn't make. Maybe Anyway, I can keep this. Okay. But anyway, this column is the month identifier from French 3-factor data, and this column is also the market identifier from the Bloomberg. Okay. Okay. Now let's go back to now let's have a review of the homework 4. Okay. Homework 4, we use IWV to proxy market portfolio, and we have calculated expected return, right? And we calculated variance standard deviation, covariance beta. Okay, and these results, we get these results using IWV to proxy for the market, right? Now we don't have to, now we are going to, in homework 5, we are going to use a market portfolio here, or 3-factor market portfolio to proxy for the market portfolio. Okay, so I'm going to replace this column, because the model has been built in the Excel, so we don't have to repeat this work, right? You have done this work in the homework 4. Okay, for example, if you don't believe that, you can take a picture You can take a picture of these results. Okay, we don't have to repeat this work. You can take a picture of these results, and now after we replace this column with this column, then the results would be updated automatically. Okay, now if you don't believe this, you can take a picture. Okay, now I'm going to replace this column, yeah, IW with the former French market data. Okay, so I'm going to this one that would be equal to this one, right? And now I'm going to move the cursor to the right bottom corner and double click the cross. Now we can see, right? We have replaced this column. Now let's see the results. Okay, this is the results. Okay, you can see expected return would change, right? Yeah, just now the expected return of risk-free rate is 1.09215, right? Now it is 1.086667. Okay, so now this shows the market expected return, or the average of market in the past 60 months. Then this is the variance of former French three-factor market. This is standard deviation. This is the covariance, right? And beta is 1. Okay, and now expected return would not change. Okay, variance, for the 4 assets in our portfolio, this number would not change, right? Expected return, variance, standard deviation would not change. However, what is this? This is covariance between HYGV and the market portfolio. Now this number changes, right? This number changes, and of course, the beta changes. Okay, so right now, we get the covariance beta, using former French three-factor market portfolio as a market portfolio. Okay, and to be safe, I'm going to rename this column. Now this column is market, former French market portfolio, right? Okay. Okay. And then, in the homework 4, we calculated, okay, I think, we did this in homework 4, right? Just as I said, only difference is, homework 4 use Russell 3000 to proxy for the market. And in homework 5, we use the former French market to proxy for the market. All right. Okay. Now, let's look at the next step. Okay, homework 5. So, now, we're going to estimate the Sharpe ratio, Turner ratio, and the Jason's alpha of the assets in the portfolio. Okay, I think that is easy, right? Step 3 is estimated expected return, variance, standard deviation, beta. We did this in homework 4. And now, step 4, following the definition, estimate the Sharpe ratio, Turner ratio, and Jason's alpha of the assets in the portfolio. Okay, now let's go to our Excel. Okay, I'm going to have more rows here. Okay, I'm going to estimate or calculate the Sharpe ratio. Sharpe ratio. Do you remember the formula to calculate the Sharpe ratio? Okay, that is expected return of a individual assets minus the risk-free rate divided by the standard deviation. Divided by the standard deviation. Okay. Because this is a market. Okay, this is market. Okay. First of all, I'm going to calculate the Sharpe ratio of market. So that should be the expected return of market is here. Is here. Okay, minus okay, just a moment. Yeah, because we need the risk-free rate. We need the average of risk-free rate. Okay, yeah. Before we move on, I have to calculate the risk-free rate. Risk-free rate is here, right? That is risk-free rate in the past 60 months. Now I'm going to calculate. I'm going to calculate the average. So I don't have to calculate from the beginning. I just scroll to the right. Okay, and then this is the average of risk-free rate. We don't need this one. Yeah, this cell doesn't make sense. I remove it. And this is the market average of market risk premium, right? And actually, we don't need this data. So I delete this, and I keep the risk-free rate. Okay, that is the average risk-free rate in the past 6 months. So I use RF AVE. Okay. All right. Now, we can calculate the Sharpe ratio. So according to the definition, Sharpe ratio is expected return of an asset here. Yeah, in this column, it is the market. Okay, minus risk-free rate. Risk-free rate is here. Is here. Okay, and then divided by what? Divided by the standard deviation, right? So it is here. Okay, so that is the Sharpe ratio of market portfolio. Before we move on, we just double check. Okay, make sure our calculation, our formula is is right. Our calculation is right. Okay, now let's see. We can check. Okay, B63 expected return minus K63. Okay, then divided by B65 standard deviation. Because later on, I'm going to scroll to the right. So I'm going to log K63. Yeah, because when I calculate the Sharpe ratio for different assets, then the risk-free rate is the same. So I'm going to highlight this and click F4. Okay, and then log this cell. Okay, this is Sharpe ratio. Of course, right now, you can scroll to the right to calculate the Sharpe ratio for these 4 assets in our portfolio. However, usually to save time, I didn't do that. I want to scroll right after I get the trainer ratio and the Jason's alpha. Okay, then in this case, I do 3 of them. I calculate 3 ratios, Sharpe ratio, trainer ratio, and Jason's alpha at the same time for 4 assets in our portfolio. So I do not do this right now. I keep doing. I calculate trainer. Come on. I calculate the trainer ratio. Trainer ratio. Okay, trainer ratio equals. Yeah, according to my rule, I should have an equal sign here. Okay. Do you remember the formula to calculate the trainer ratio? That should be expected return. This one minus risk-free rate. Risk-free rate is here. Of course. Yeah, I'm going to log the risk-free rate. So I click F4. Okay. And then divided by what? Divided by beta, right? Beta is here. That is here. Okay. Then this is the trainer ratio. This is trainer ratio. Now, yeah, I'm going to calculate the Jason's alpha. Yeah, I just use alpha, right? Alpha. In order to calculate the Jason's alpha, I calculate. Okay. I calculated the expected return estimated with campaign. All right. So I name, yeah. I name this one, yeah. I use this notation, okay. Expected return. Expected return for campaign. CAPM. All right. It is expected return. I use campaign to calculate the expected return. This is the expected return that reflects the market risk factor, right? Okay, so if you remember the formula, that should be risk-free rate, right? Risk-free rate. Risk-free rate is here. Okay, because later on, yeah, we're going to scroll to the right. So I'm going to log this number. Oh, come on. Come on, where? I close it. All right. That does not make sense. Okay, give me a minute. I just I accidentally close it. Okay, but fortunately. Okay, all right. I think, yeah, I'm going to pause here. Let's take a rest for a while. I'm going to continue later on, okay?